Thanks so much for tuning in. This week we are playing with colors on the web. You know why? Because it's my birthday, and I want to play with colors. And it's my birthday, so I get to play with colors. So I want to show off some color manipulation libraries, some code, talk about color formats, how you interchange between them, some ones maybe you didn't know about, and then showcase some really cool stuff that people are doing with color on the web. I think any other fun ideas, throw them in chat and we will take a look. I'll start off today with a thing that I built a long time ago, but I want to sort of play with. So you can see, because I just think it's a really, really neat little tool. It's a color picker. It's on Glitch. I'll throw a link to it in the channel. But it's just a really basic color picker. The cool thing is it is live, which means as you drag any of these sliders, all the other sliders move. It's really fun to like grab the hue slider and then watch all of the like red, green, and blue sliders dance. And then watch all the numbers live update. I just have a lot of fun with this. It's also really useful. You find a color you like, or you find a color, you know, maybe something a little bit less putrid than this. That's a cool green. You can save swatches, pull them back up, manage them. It's a really simple color management tool. It's super useful. Sometimes you're just like, oh gosh, I need that, you know, I need pink, but darker. And you can just like do that, save a swatch, and you've got it. Super easy. There's clipboard buttons here. You click these, it's gonna copy those formats. And supports alpha. So anyway, colors. I'm a huge colors nerd. I really, really like playing with colors on the web. I love people when they use color really interestingly. And I just would think people should spend more time thinking about color because I think color adds a lot of personality to stuff. Glitch, we don't necessarily shy away from color. And when I say color, I don't just mean like the 4 colors that every company logo is, blue, red, green, and, you know, blue, red, green, and yellow. I mean like making some cool stuff. Like, I mean, look, come on. The Glitch logo is like pink and purple and blue. This pink is a dynamite. Specifically, we're going to play with them on the web. So I'm going to talk to you about colors and the way we mostly interact with color on the web, which is via CSS Colors, right? So I'm going to throw this link in channel so you can all follow along. Colors in CSS is sort of, even when you're not using CSS, you're using JavaScript or Canvas or any of those things, you still ultimately end up using these sort of CSS standardized color values. They're sort of how the web uses and manipulates colors. And there's a couple different ways you can talk about them. There's sort of the classic hexadecimal color, which I think everyone who spent any time on the web playing with is familiar with. You know, you've got your, you know, these, right? Your hex, and you've got these 3 different sections. The first 2 hex digits are how much red, the second 2 are how much green, the last 2 are how much blue, and you can change it and actually see that change here live. You know, so if you're familiar with hex, I feel like hex colors are super common. They're all over the web. They're kind of impenetrable, right? Like I've been around long enough that I can kind of look at this and say, oh, it's going to be more red than green and more green than blue because I can see the individual hexadecimal digits and I know that this is 255 and this is about halfway. That's what, 120 something. Actually, no, it's 136. But you also have all these more verbose ways to talk about color, right? So FF is 255, CF is 207, 88 is actually 136. 8888 is not actually true halfway gray. It's actually higher than halfway gray, right? Which means that 888 is actually the same thing. I always think that was kind of interesting that, you know, how short the shorthands work for this stuff. If you've never used color shorthands, you get things like FFF. It's the same thing as FFF, FFF, which means that's actually duplicating the characters, right? So 111 is 111, 111. And so you're not always getting exactly the color you think you're getting. Specifically, I think 888 is a great example, where 888 is not the same thing as true halfway gray, which is 808080. They're pretty much the same thing, but it's neat that I think that there's a difference there. So anyway, right? We've got hex. I feel like people use hex forever. RGB is really useful if you know what the exact color numbers are and you don't feel like doing math. Right? RGB also gives you access to RGBA, which is red, green, blue plus alpha, right? And the first 3 numbers are from 10 to 255, and the last one's from 0 to 1. It's a little unintuitive that they don't all match, but you could actually specify alpha. You can see in this example, I will add alpha to things if you make them less opaque or more transparent. And then there's HSL. And HSL, it lets you talk about what color it is as a hue, and then how colorful it is and how light it is. And I love this. I love the relations between these things. I think one of my favorite things is to just like let's take a color like red. I'm gonna start with red. It's gonna be very intense. Sorry on the stream, but like, okay, so that's all red. And the hue HSL, the hue value is 0. But now watch as I move the hue slider. I think this is cool. As I move the hue slider, you're gonna see green go up, and when green's gonna go up and 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 up until it hits yellow. And then the next section of the hue is red going down. So it's like, you're moving the sliders, but there's always one slider up, right? So now there's 2 sliders up. Now we're going back down to just 1 slider up. Now the blue slider's coming up, but as soon as the blue slider hits top, the green slider goes down, and then the red slider comes back up, and that completes the circle, and the blue slider goes back down. So hue is this like cool, it's the color wheel. And I've made a little app to visualize this that it's actually linked in the channel already, which is CSS supports a bunch of named colors. I don't know if you're familiar with this, but there's all the obvious ones like black and white and red and all those. But if I scroll down here on this page, you can see CSS supports a lot of really weird colors by name. Some of them are what you'd hope they'd be, like lime. Okay, sure, bright green. Or purple. Okay, that's a purple. Fuchsia. Okay. But then Alice blue, which is like blue, but not all the way. And antique white, which is actually kind of a peach color, but it's different from bisque. And blanched almond, which is also kind of the same color. And then azure and Alice blue, they're not that different. And it just goes and goes and goes and goes and goes. And some of my favorite ones in here are the ones that just make no sense. Like burly wood. Is that the color? That's burly wood. What are some other incredible ones here? Papaya whip is a famous one. Lemon chiffon, lavender blush, right? It's lavender with a little bit of pink in it. Why do we support these colors? There's an awesome conference talk out there that explains exactly where all these dumb color names come from. I'm gonna real quick pull it up. This is actually harder to find than I thought. Here we go. Peach puffs and lemon chiffons. We're not going to watch this, obviously, in channel, but it talks about the origins of the CSS colors, and I think it's awesome. So I'm going to throw that in here. It turns out they all come from, like, X11 days, right? So you've got a bunch of Unix nerds with poorly calibrated monitors literally holding up crayons to their monitor and being like, well, there's a color called mint cream in my box of 64 Crayola, and that looks like mint cream, and then they type the hex values and they make it look right, and that's it. And then because the web comes from old Cerny Unixy systems, at some point someone was like, let's just support all these color keywords, and as a result, the web has Navajo White, which is a couple like maybe potentially problematic names in here. But then you've got, Papaya Whip and Peach Puff and Peru. Sure, is that the color of Peru? Why not? I decided I want to plot them. And so what I did is I built this app called Evening Astronomy. In the grand tradition of projects with wonderful glitch names. I'll throw the link to that project in here. And it's a plot of the CSS named colors to the stream here. But so all of these, I don't know if you can see, maybe I'll even bump the font size up of the color names just so in the projects people can see what they look like right now. We're going to make them like 14. There we go. I hope you can see that on stream. Now that they're a little bit bigger. But we've got all these colors, and it's hard. One of the things that's fascinating is they're like super not evenly distributed, right? Like, look at this wedge over here. Look at this wedge of the pie. Look how many keywords, how many named colors are in this named wedge. And then look down here in the greens. There's like this completely dead wedge, or like all of this purple, kind of pale purple, nothing. And then like up here, where like brown and gold and yellow and skin tone is, like super filled in. I don't know, I think that's neat. And this is a plot of hue and saturation, so how intense the color is versus how intense the color is on the HSL scale versus what color it is in a wheel, right? So that you can sort of see red goes into green, into blue, into purple. It's a color wheel. All the rest of the plots are actually versus luminosity. I can jump into luminosity a little bit, but luminosity is not the same thing as lightness in HSL. Lightness is sort of just on the scale from 0 to 255, but it doesn't take into account how your eyes see color. So a lot of times when people, you'll see what I mean when I scroll down here. But actually, I'm going to go to the very bottom plot because I think this really shows the difference. This is a plot of lightness versus luminosity in the CSS named colors. And you can see that, like, technically, lightness is the x-axis here, and you can see white on one end and black on the other. But then look right in the middle where the 50% line is. That's where all of the like primary colors live. And you've got yellow and blue. And according to CSS, yellow and blue have the exact same lightness on the HSL scale, 50%. But if you look at luminosity, and if you just look with your eyes at like a rainbow, you can like the normal color wheel, you can tell that blue seems darker to your eyes than yellow does. And in fact, if you do the luminosity calculation, you can see here that there's a huge difference between yellow and blue in terms of how visually bright they are, as opposed to how computationally intense of red, green, and blue they are. And I just thought this plot really shows off why sometimes you need luminosity. And one of the more important reasons is because of contrast, right? So you've got, if you look here, I actually right at the 50% line, I don't know if you can see this, but right at the 50% line, I am actually switching the color of the text on the labels because I want to make sure that the text is readable, right? If up here I put white text on yellow, you wouldn't be able to read it. And likewise, if I put dark text on here, it might be very hard to read. So if I was to use the lightness value, right, it would tell me that both yellow and blue would deserve the same background color, which is, you can tell, obviously false. So the luminosity calculation lets me figure out, right, 50% line, I can sort of flip from a white label to a black label, and I know that it's going to be decent contrast for human eyes, which is just more accessible, it's easier to, just more pleasant to look at. Luminosity, super valuable calculation. Highly recommend you using that. I'll jump into the code here in a second because I think talking about luminosity is worth it. Some other cool plots, saturation versus luminosity. I like the hue luminosity just because this one really underscores how uneven the CSS named colors are, right? Like, look at this. Look at these huge empty regions. We've got all of these colors over here. We've got all these colors down here. And then there's this weird desert with lavender smack in the middle and lavender blush kind of holding up this end. But there's no like, I don't know, there's no colors in here. I think that's weird. It's why maybe named colors are not always the best way to do things. But I think they can be a lot of fun. I think it's fun to read CSS and have it say like cornflower blue or deep sky blue or dark khaki. There's some really weird long ones in here. Medium sea green, pale goldenrod, light goldenrod yellow. They might be one of my absolute favorites. Why do we need light goldenrod yellow? Especially because lemon chiffon is almost the exact same color, and so is beige. Anyway, so I'm actually going to go into the code for this application because I think the code for this is really kind of one of the great things about it. And what I actually wound up doing was I wanted to figure out luminosity from colors because I just didn't think that the normal HSL values were enough. But you can see I do these different plots, right? And I've got a plot here for hue versus saturation. I figure out the angle, which is just taking the hue value, which goes in 0 to 360. So I can say hue goes from 0 to 360. I'm just going to switch to this window. There we go. Oh, I actually know what's going on there. That's not important. So yeah, hue goes from 0 to 360. I convert that to an angle, and I can plot things, right? And I'm just plotting everything by percentage, which makes these plots nice and scalable. I probably could have used D3 or something, but I was feeling lazy. So you can see each of these plots uses a different thing, but I am doing this luminosity check, where I take the color in its red, green, blue values, and I say, is it less than 0.5 or greater than 0.5? And I switch from white label to black label, depending on which one it is. So what is the luminosity? I have this magic function I've imported from a library called Colors.js. Colors.js is a file I defined with a bunch of different functions in it. And we can actually take a look here and see, here I have a list of all of the named colors that MDN lists and their hex equivalents. And then all the way down here, we can play around with some of this stuff a little bit more. But we've got, we got right here, this function called luminosity. And what it takes is it effectively just takes red, green, and blue and scales them depending on how bright they are. And that comes from, there's just these like coefficients that are known. It's really just like a fixed bit of math. I learned about it from this Wikipedia page, which is the page on YUV. It turns out that this is actually the format that old television signals were transmitted in, right? It's a Y, which is how bright everything is, and then UV, which are color components. They talk about luminance or luminosity. Maybe I should be using the word luminance. I'm not a image processing dork. Maybe this needs to be luminance. We can fix that sometime. But all the way through all of this stuff, sure. But right here in the middle, you see YUV is computed from RGB, linear RGB, not gamma corrected RGB, as follows. And you can see there's these three numbers, 299, 587, and 114. And also you can see that it says linear non-gamma corrected RGB. So, two pieces of information here. When colors are drawn to the screen on most monitors, they are not drawn linearly. 000, 128, and 255 are not evenly spaced. And that is plotted, colors are actually drawn using what is called a gamma curve. And a gamma curve takes, we're gonna get sciencey here for a second. I'm actually gonna open up the graphing calculator. Fun fact, did you know that every Mac comes with a built-in graphing calculator? And we can say, it's gonna be X to the, and we're gonna say 2.2. Okay, and really what we want is to look at this on the range of 0 to 1. So let me see if I can zoom in here. That's not how you pan. That's how you pan. Equalize axes, and then zoom in one more time. So we now have, zoom out one tiny bit, and you can see we've got this plot. So as opposed to going, I can zoom back in, 0 to 1. As opposed to going in a straight line, right? Maybe I can add a second plot here. I can say y equals x. And then I'm going to add a third plot because I can say y equals x to the 1.8. And you can see here, as opposed to, just about all fits on the screen, going from 0 to 1, as opposed to going in a straight line from 0 to 1, which is what y equals x does, the curve y equals x to the 2.2 is a shallow curve, and it kind of scoops in to going toward 1. Smaller, at the beginning, smaller changes make a smaller effect, and then right around halfway, it's about equivalent to linear, and at the end, small changes make a big effect. And that's just a matter of how monitors work and how our eyes work. I don't understand this stuff super well, but you can see that there's what's called linear RGB, which is this, and sRGB is gamma corrected. And the gamma is literally just this exponent. Macs, almost all Mac computers tend to use a gamma value of 2.2, but different computers use different gamma values. 2.2 is pretty standard these days. 1.8 is another 1.8 is another value that I've seen in the past. I'm going to see if I can find gamma curve. Yeah, we'll drop this channel in. Drop this in the channel in too. We are dropping science all over the place today. And you can see what the difference gamma correction makes is if you look down here, right? You can see the different exposures on this image. And really that's what it is. Gamma is about exposure. So anyway, I have to take the red, green, and blue values provided from CSS Colors and correct them for gamma before I scale them. Otherwise, the luminosity calculation just isn't correct. So mostly this function is doing a lot of heavy lifting, right? This function assumes that you know what gamma correction is, and it assumes you know what like YUV calculations are. So maybe I should just like throw those. Maybe I should just throw those right into the that was higher up conversion from RGB. There we go. And just throw those right in the code because I actually think it's useful. Simsword, thank you so much for following. I'm going to throw a link to this in the channel in case people want to play around in the code. There's a link in the channel. So you can see that we do gamma correction and we scale the color components, and it actually gives us a more realistic version of the colors. So what we could actually do, and I think this will actually be fun, is I'm going to create a new project. I'm going to remix this project, and we're going to do a new color plot. And I'm going to do a color plot where the x-axis is hue and the y-axis is luminosity, and it's going to kind of show you how the CSS colors or how like all the web colors sort of vary. So we're going to do a little bit of remixing. I'm going to start with this evening astronomy project, and we're going to go into a muddy print. But this time we're going to be playing with canvas because I'm going to keep the script, but I'm going to actually more or less blow all of this away. We're going to say let canvas equals, keep my one line, and I'm too lazy to grab jQuery library in here. And we're going to say this is a hue versus luminosity plot. So we're going to actually keep that label, and we're playing with I'm going to actually correct this for luminance. So we're going to say web color luminance because I've learned that the term I was using was wrong. So let's use the right one, shall we? Okay, so if you're just joining us, we're going to take colors and we're going to plot them based on how visually bright they are as opposed to how computationally bright they are. I think this will be a really instructive way for people to play around. We have this little library on our page called colors.js that I wrote, which is just a couple color conversion functions. It lets me pass red, green, and blue and get HSL out, and that lets me pass HSL in and get red, green, and blue. We're going to take advantage of that. So let context equals can't type because people are watching. Also can't type when people are watching. Let's give our canvas some width. Let's say canvas dot width equals, let's just do 720. And then canvas really can't type equals, we should probably put those in quotes. We'll do 100 pixels. So we can see maybe 200 because I scaled both axes by 2. Okay, so we've got a canvas and we are going to just make sure it works. If I fill this, we should get a black rectangle, assuming there's a canvas on the page. As you can see, nothing happened. Oh, it's not auto refreshing. Let's try spawning that one more time. See if we can get it to auto refresh for us. Good enough. So instead of doing that, we are going to say for let 0. Or actually, not I. Let's use a descriptive variable here. Hue equals 0. Hue is less than 360 because we know the hue range. And we will loop over hue. And then for each hue, let's do a fully saturated. Oh, thank you, Fubarius. Let's do a full swing of the fully saturated lightness values. So we're going to keep saturation at 100%, and we're going to keep saturation at 100%, and we're going to vary the lightness. So you can see the difference over time. So let lightness equals 0. And that way we can loop over them. Okay, so we can say let color equals, really bummer that's not auto refreshing. That's okay. Let color equals, it's going to be, I define all these as variable, all of these as sort of HSL values, or sort of triplets, arrays with 3 elements. So, right, this is going to be hue, saturation, which is 100%, and then lightness. And I can actually then say let RGB equals HSL to RGB color. Then I can say let, I really want to, this is actually, we're going to break everything and then fix it. Saying luminance equals, lum equals luminance GB. And so now we're going to have a luminance value from 0 to 1. So I'm going to go quick in and fix this function name because I'm annoyed that I used the wrong term. Cool. Aha. This WCAG contrast ratio thing, I'm not 100% certain that it's correct. So I've been, I'm a little bit loath to demo it, but it is a cool idea. It's the idea that you can use luminance to actually figure out the contrast ratios, make sure your stuff is accessible. Maybe we can play with that in a little bit as well. So we've got luminance, and now we can actually plot these things, right? We know we can now actually draw a rectangle. First, let's make sure our color is set to the rectangle. So we can say context.fillRect or fill style, and we can say RGB to hex and pass the RGB value. Then we can say context, not importing RGB to hex, so RGB to hex, import that. And then we can say context.fillRect, and we'll do hue, and then we'll do, instead of, we know the lightness, what the lightness should be, but instead let's say hue times 2, because we're going from 360 to 720. Lum times 2, we're going to start at we're going to plot it vertically, so we're going to flip that, and then we're going to say 2, 2. If this worked, and I refresh, I don't have an infinite loop or something terrible. I must have an error on the page. Let's take a look. Any errors? NS not available. I don't know if that's the right one. Let's see what we've got going on here. It doesn't seem to be drawing anything. I wonder what's going on. Let's say change this to just be low or red. Let's make the color just red and see what happens now. NS not available. So something's going on here. Maybe we're having some browser trubs. We're just going to refresh this page. Browser trubs happen. Aha! Now we have a red line. Okay. I feel like we've potentially fixed something here. So let's say RGB to hex. RGB. Okay. Now it's empty. I'm going to guess that if I take a look at the function definition for RGB to hex, that I forgot to do something. No, that looks okay, doesn't it, right? RGB to jex, apparently it's not a real function. RGB to hex, RGB. Heck, let's just start doing some console logging here, shall we? We're gonna fill our console with a bunch of garbage. Ooh, and we properly choked my computer for a second there. But there, look, colors. Ooh, wow, I've really trashed my computer. That's what happens when you log 360,000 items into your console. It takes a small nap. Oops. Big oops. Oh, come on, it shouldn't be that bad. Yeah, stop. I don't know what's going on here. Okay, moral of the story, don't do that inside of the loop. Mumtastic, hello, thank you so much for following. Okay, so instead, aha, I know what it is. And what it is that luminance is from 0 to 1 and not 0 to 2, not 0 to 100. So in fact, I need to make this like that. Ah, look at that. All right, so now we've got a plot. I'm actually going to pop this into a new window because I think that is worthy of zooming in on. So I don't know if you can see the difference here. Maybe I'll even double this. Let's really go for it. And then let's make these. And then let's set the background to black so we can really see what's going on here. Or maybe medium gray. Context dot fill rect 0, 0, 1440, 400. You can say times 4, 400, 400. Okay, here's our plot. And now you can see what's going on here, but look at these middle values. You get these curves. And those curves are showing you that, look up here, you can see the yellow, like medium yellow, is very, very bright. And medium blue is almost entirely dark, right? So maybe we can focus and say just the lightness to 50%. Then we can skip. We can just plot just middle, just the actual fully intense color. Yeah, there we go. Okay, so you can see that even though these all have the same lightness value, I'm still using luminosity over here, right? Even though these all have the same lightness value, they don't have the same luminance, right? Your eye sees blue much darker than your eye sees yellow. And you can see the different peaks as we go through the hues here. Like orange goes up and up and up and up and up, and then it stops at yellow and comes back down, takes another peak at cyan, it goes all the way down at blue, and then pops back up for fuchsia, and then levels back off for red. This is, I think, striking to me, personally, because this tells you that, like, HSL is a pretty imperfect scale. Maybe is the best way to describe it, right? Like, HSL wants you to treat blue and yellow as the same lightness, and they're just clearly not. What else can we do? Now that we are armed with phenomenal plotting power, let's play with contrast. Let's take a look with contrast. If you're not familiar, contrast, the term, especially the way I'm using it, refers to how easy it is to see two colors when they're stacked on top of each other. And, you know, contrast is sort of a... Oh, cool. Fabaria says, I've learned about luminance years ago and being a monochrome LED matrix, but it never occurred to me to plot it. Yeah, I just think this is, like, super telling that you can see how wildly varied when the bottom line here is 0 and the top line is 1. That, like, how completely different it is. And oh, for LED matrix, that is cool. I love that. So I guess you're trying to figure out, like, how to make things be even brightness or be you know, linearly increasing in brightness, even though, you know, you're changing the voltages a certain, you know, different amount. That's always tricky. Getting in, and this is where this stuff gets tough with gamma correction and all that stuff, where you're trying to go from computer perfect, right? The idea of a perfect computer number that goes from 0 to 255 in a straight line, and the real world where, like, you know, LEDs and LCDs are actually emitting light, and it's going into your meat eyeball, into your meat brain, and how those two things don't line up. It gets very, very messy. We are just tap dancing across the top of the surface of color theory, because honestly, I'm not smart enough to do more of it. I have not spent that much time deep in researching it. Oh, okay. So you're using it for one color, and the input might have been RGB. Yeah, if you were treating full intensity red and full intensity blue the same, your grayscale is gonna. That's cool. Fubarius, when you were playing with the luminance, you said you put the luminance stuff in. Was it a similar formula or a similar equation? I'm kind of super curious now. That sounds like a really fun project, and that would make you learn this stuff whether you wanted to or not. I'm gonna do. Let's do. Contrast over, or let's call it white text contrast. So for this one, instead of plotting colors, we're going to say, we're actually going to try to compute what the accessibility contrast. We're actually going to try to compute what the accessibility contrast of a certain color is when there's white text on top of it. So we're going to create a second plot, and we're going to, so we'll have a second one down here. I'm going to change up my script to fetch. Barbarius1, thank you for the follow. Appreciate it. And we're going to say this was .hue, and then we're going to go down here and just duplicate this code to start and say contrast. Let's make the same. And also, let's just really quickly say that our canvas values, they're going to be max width, just because I know it's going to be 100 VH minus 4em. Just that way, if someone takes the window and shrinks it down, it still works. That first plot was not called Hue. It was called Hue. Oh, right. Let can't happen twice. That's fine. Okay. So, still that plot still isn't plotting. Interesting. Double let. Okay, here we go. So the second one is going to be a various color with white text on it, what the contrast is. So contrast is just a raw number. It can be 0, where they're literally the same color, and it can be arbitrarily high. So we'll have to be a little bit careful how we plot this. But we're gonna start and say same full contrast color, and then we're gonna go take a look at the contrast code, and it is the contrast ratio of A and B, and I think it's A over B. Actually, looks like it'll go both ways because it's math.max, math.min. The WCAG is the Web Content Accessibility Guidelines. It's a set of standards that talk about how to build accessible websites. It's really cool, and it has the benefit of defining precisely how you can figure out the contrast between different colors. So I'm going to, I kind of coded up that coded up that, oh my logs are all worked. I coded up that formula and just export it as a helpful little helper thing here. So if I can import contrast, I can do, and then we can, instead of computing the luminance directly, what we'll do is we will say let contrast equals, and we know one color, it's going to be white, and so we'll pick the other one, and then we'll just, the arguments to this function takes red, green, blue. So we know It'll be contrast, 255, 255. And then our color, which we can pass as RGB. And so now we have a number for contrast, and we can say, I don't know what these contrast numbers are going to look like. So we're going to start by saying contrast times 10. Like, we could be using a plotting library for this. I understand. I feel like I'm really leaving us out to dry. Import not found contrast. Did I not export it properly? Have I looked at the word contrast too many times and now I don't know what it looks like? Oh, it's contrast ratio. That's fair. All right, so you can see that it does vary. But let's maybe we should at some point switch to using like D3 or Chart.js or something like that, just so we get a better feel for this stuff. Because right now I'm just randomly mashing in numbers. But you can see, and actually we're gonna make the background context.fill style equals FFF for white. Cool, so you can actually kind of see what white text contrast would be. And you can see green and white and yellow and white is very, very low, and blue is like acceptable. When you consider that the 50% cutoff line is here, these two plots are kind of inverted from each other because white's a very specific color. But like we could pick any color, right? And we could say 128. You could pick middle gray. And actually what we should do is, now you can see that it's that kind of more of a complicated story where it bounces around. But what we should do is actually let you pick the color and let you see what the contrast is. So let's do that. That would be fun. So instead of, it's going to be text contrast, and it's going to be, we're going to let you pick the color. So we'll put an input here. Input type equals color. And we'll just give that a class of contrast color. Cool. So we'll actually let people, oh, that sits in a really weird spot. Actually, you can put that inside the header. I think they'll just be easier to find. Okay, so now we have a color picker, which is another way we're going to play with color. Modern web stuff actually has the concept of inputs with a color type, which is really useful. But what we can do is, for contrast, we can say let text color equals, and we can say, I think we called that value, and then we have the idea of a text color. And I should probably log what that is. Let's take a look. If I log what that is, it is a hex. I don't know if you can see that down here, but it's a hex, which means we can convert it. So first thing, we can actually plot it, but then we can actually instead say down here, we know it's going to be a hex, so we can say hex to RGB text color. And that lets us properly compute the contrast ratio. Now, right now, this is only happening on start. So what we actually need to do is maybe function contrast plot. Make a function called contrast plot. Inside of it, we can actually just take all this code and hoist it in. We can now define canvas in context locally. And now we can call contrast plot on page load. We can also say, when contrast color can also, when we change it, update the contrast plot. Okay, so now you can see on black, our current scale is all terrible. That's okay. Let's pick a light color like yellow and replot. Hey, all right. So now we have the ability to actually see text contrast between various colors. We can actually potentially set it to darn near white. You can see it's pretty low. We could set it to all the way yellow. If it's all the way yellow, then the contrast should be effectively 0 when they match. It doesn't actually seem to be 0, which is very interesting to me. I wonder what's going on there. Maybe my contrast math is bupkis. The other thing we can do is right now, we are only updating the plot when it changes. We can also listen for the input event. What that means is as we actually surf around in the colors, we should be able to watch the plot change. I think that is very satisfying. You can see there's definitely something going on here with sort of plot position, where I feel like 0 should be 0 and it isn't. So maybe I should take a look at what the WCAG contrast ratio rules actually are. Or maybe that's just what they are. That's interesting. Let's look it up, because I want this math to be right if I'm going to share this around. Do a little bit of learning. Color contrast checker. How is contrast ratio challenged? Woohoo! Look at that. It is complex. I don't know if you saw it. So they're doing, so you can see this, but they're doing some, you can see the gamma correction. Their gamma correction is 2.4, not 2.2. Okay. And then contrast ratio plus 0.05 plus 0.05. My code is what? Plus 0.5? 0.5? Oh no, 0.0. Okay. I feel like I'm on track here. Contrast ratio is equal to or greater than 7 to 1. All right, so it sounds like we're going to do our own crappy job here, then we need our own crappy plotting library. So let's make a crappy plotting library, shall we? And let's leave the background. I'm going to say leave it. I'm going to make it gray all the time so we can actually see the plot. Like so. We're going to make a little function called scale. This is terrible. Just use D3, but we're here. So we're going to make a really simple scale function. It's going to have, it's going to be Y. It's going to be like, so we want a range and a domain. So we're going to be A, B, C, D. And that's going to be from, so we want to take A, B, C, D, V. What this scale function is, basic Y scale. And we can say, is the domain, is the range, V is the value. So we can now take a number from 0 to whatever and plot it, map it linearly to our plot. And so what that's actually going to look like is we can say V, it's going to be, so we want the input, so the input is going to be V minus A divided by B minus A. And so that gives us a value from 0 to 1 within our input range. And we can return the output, which is going to be input times D minus C plus C. And what that lets me do is I lets me map one set of values to another. And so instead of this nonsense right here, I can in fact instead say, scale, and the input scale I'm going to say is from, say, 0 to 10. And then the output scale is going to be from 400 to 0. This is cool. This is my output drawing. And then the input value is contrast. Cool. So you can now see some of these contrasts are off the charts, are way higher than 10. So we can say let contrasts equals, we can say and we're actually going to run over all the contrasts once, and then we're going to run through all the contrasts again and plot them. And what that lets us do is it lets us say let min equals dot min contrasts, let max equals and now we have the minimum and maximum value, and then as opposed to me guessing what the minimum and maximum value are here, I can actually take the computed ones, and we can say contrasts dot for each, and now we have for every value we computed, oh, and we can also extract the hue, so we can say contrast hue, take these two numbers, move them up, and go back. That was a lot. It went really fast. I probably made a bug. I didn't close this. But we're going to say find the range of output values, plot using the range. Now I'm going to output some statistics also. Oh. I see. Let's just fill style black lines right now, because I don't feel like recomputing these. So let's just do. Okay, what do we have here? Looks like that. So you can see we go from 0 to the max value, and as I move around, it changes. I think that's pretty cool. Okay, so this is sort of a label-less plot. But it is the beginnings of like a useful bit of information. Okay, so we have these values. We have a plot. The plot's a little anonymous in the sense that we don't know what the values are, but we did compute the range. So what if we were able to say summary dot inner HTML or text equals min contrast. Excuse me, I'm streaming. Thank you very much for streaming. Max contrast max, and then we should actually be able to make this summary be a thing. Right now it's not. So let's say let summary equals, and then we can add a little summary to our text contrast thing. Like so. Cool. So now you can see, I need to remove that. I need to remove that second input because it's just confusing me. By the way, if you're following along and you want to take a look at this code, I can drop the link to the project right here so you can actually go take a look at what we're doing. If you click that link I just dropped in chat, you can actually jump in and browse around the code and take a look at the project along with me, which is kind of nice. So we've got just one input now, and that lets me do text contrast. And I want to bring the colored output to the plot again. I really liked the colored output. So instead, we can do contrast hue. And then actually we can say, let the minimum value equal infinity. Let the maximum value equal negative infinity. Because we know what we're tracking. So we can say min equals min contrast. And as we iterate, we can update the minimum maximum values. And we don't have to compute them like this. And then we are extracting the contrast and the hue and the color. So we're going to grab the color out of here too. We can do RGB, and then we can put this back to be oh, I have a very hungry cat behind me who deeply believes it is dinner time and is wrong. Cool. So now you can actually see the actual input and output max contrasts. So if we are drawing on top of orange, the best contrast we can get, and this is what are the comparisons here? It's fully intense. The blue on top, this color on top of blue, the best we can possibly do is 5. I don't know, my math is perfect there, but you get the idea. You can see up here, I think the math is not exactly perfect because these numbers should go higher than 7, but you are seeing that there is a contrast here. So maybe we'll take a look at that contrast math again. Because it does not seem super accurate. So you can see like these, it says the contrast ratio is 8. Obviously my math is not correct. So we should figure out, I should figure out what that is. Just tells you it should have it. Ooh, this is. Let us see. I'd love to get my math right here. I could have sworn I had it, and it does not seem like I do. We're just... Seems like a lot of people have done it, so let me figure out if I can do it. Is this okay, so this project has a GitHub repo. Cool, Leveroo. Oh, Leah. Leah's great. Let's take a look at Leah's contrast ratio.js. I'm super curious about what the math is here, and we will give credit because Leah is awesome. Somewhere in here, there's going to be maths, unless I completely missed it. Range intersect, sure. Update luminance. Update. So if there's the math in here is everywhere. The math is scattered to the winds. Update luminance foreground, update luminance background. Ah, so it's a color library. There's a color library in here. And this seems like where all the good stuff is. Aha, and this uses the WCAG, the WCAG. This uses the WCAG luminance stuff. I see. So this is a very specific function. We're gonna call this. I think we're just gonna kind of borrow this code with credit. This contrast ratio is an MIT license. Let's make sure we're being kind. We'll make sure our stuff is properly licensed because I want to use with credit. Looks like they're passing the color in as an array. Oh, I see. I'm going to rewrite this slightly. We're going to do color equals color.map component. And then we can say components are, ooh, I jumped all the way out of the way here. And then component is 255, just like that. Component make a comment here. And then I guess we just actually just return that value, don't I? That's an interesting little formula. And then it has me using different coefficients. This is super interesting. Okay, so now we have new code. New code. Return component. Yeah, that makes sense. That's not. Aha, look at our contrast numbers. Now our contrast numbers look awesome. So now we can say yellow on yellow. Still kind of surprised that it's 1, but it's maybe 1's the lowest possible in the WCAG system. But now we've got nice WCAG contrast curves. So we're going to actually be able to take a look at, you know, when you're using a color, what color can you use as background and what that contrast would be. I think this is the interesting of the two plots, so I'm actually going to swap them on the page. Also, so I don't have to scroll as much. Cool. So now we can move around and take a look at all the contrasts and watch the contrast update. This is satisfying. I'm going to set the lowest possible contrast at 0 as opposed to mid. And then I think we should draw lines. I think we should draw a line at 7 and at 3.5, which are accessibility ratios. Pull up the MDN page for this. Maybe. $7 to 1 at level AAA and 4.5 to 1 at A. So we can actually draw lines to show where that is on the plot. I think this will also be cool. So we've got a range, which means down here we can say context dot and we're going to draw some lines at our AAA and AA marks. So we can say 0, you can say 0, and then this can be scale. So yeah, 0, max, 400, 0, 7. Because we know that that is the, we can say canvas dot width 1, and then we've drawn a long line at AAA and AA. And if we do this, I think it was 4.5. Assuming I didn't make errors, which I definitely did. AAA line. There. Okay, so now our plot works as follows. You can select a color, and if you move it around, you'll see AAA and AA lines. So you can see with this color, only bright yellow. Only bright yellow passes muster. We should label these lines. I think that'd be cool. So we can say say 1, and let's draw at the second one. If it's kind of ugly, the text, so let's say context dot font equals this looks a little chunky, but that's okay. Good enough for us. Okay, so now our plot has AAA and AA lines. Yeah, we can do that because we have a couple different things in here. So we can actually draw a couple different sets. We can do for let sat equals, or lightness equals 30, lightness less than 70, less than or equal to 70, plus equals 10. We have the ability to just kind of do that. And now we should get multiple. Yeah. Then we should. And then we actually have the ability to use the scale on X axis also, which I think I'm going to do. And do 20 minus 20. Oh, the input value is 0 to 360. And I can pass in Hue. And now I'm drawing like that. Okay. I could now do canvas minus, let's do 50 and 50. But the reason I want to do that now we're making a plot. Now we're plotting with gas. And I have the ability to replot this whenever I want. I can put some other smart, cute axes on here, which I think I'm going to do. So we're going to do, because I can. And isn't that what's important? What I'm going to do is I'm actually going to plot an extra label. So it's going to be fill text lightness. Oh, I hadn't considered that. How am I going to know what they are? This is me being a little bit over clever. What we're going to do. And that will let me do if I define contrast there, I could do the following. So now I can push, now I can push some values here. So I create an array that lets me collect a bunch of y-axis labels. So I can say for this lightness, I was at this contrast at the end of that row. Which also means I need to do each row individually. Now we're getting into mess here. So we're gonna quick do something so I don't create an accidental infinite loop, which is just, I'm gonna type some gibberish here. Great. And that lets me just kind of swap these loops. Right? And then If I swap these loops, now lightness is at the outside. I define contrast. Sometimes if you have code that auto reloads and you like are messing with loops, you cause infinite loops, and that's bad. We don't want to do that. So we are now, we can push lightness and contrast for each, so the final contrast value for each hue row. So at the end, we have the last contrast value. We can push it along with the current lightness value, and that gives us these Y series numbers, which lets me say this is 360. And then the hue, so these are actually, and they were, the two values were, lightness, contrast. So let's restore those values. We want to write the word lightness, but we also want to take the contrast we passed and draw with it. And then this is fill text, so it doesn't take these arguments. If I did this right, we have an error. That's, oh, because I left my loop protecting error in. Argument list error, line 79. We're bouncing around. Got one scale here, second scale here. So what's the error here again? Oh, that's the error. Oh, and then we reset. We're really close. That actually looks really good. But I need to reset the fill style back to black. So, okay, here's what we did. That was a lot. And there was a lot of me thinking in my head also. So forgive me. But what I just did is now we have this plot. I'm going to make this plot, make it lighter. And then let's make it taller. Anywhere else I'm assuming canvas's height? There is. Okay, so here's what we've got. I think this is very cool. We now can take a color and we can move around, and as we move around, it's going to find different so you can say at different color light, at different lightnesses, what the contrast is. And I'm just sort of plotting here, putting labels where this is a lightness of 30. This is a lightness of 70, and you can see the contrast goes down and down and down. If I switch it to black, they flip. Now 30 is all the way down here, and a lightness of 30 never hits AA contrast. A lightness of 70, however, does hit, actually not only hits AA contrast, but hits AAA contrast. So you can know that you probably want your color to have at least a lightness, or in this case, at least a look, okay, on black. So I don't think my contrast calculations are flawless here, to be fair. But I think that is a neat effect. So you can see the hue on the x-axis, the lightness on the y-axis, and the contrast are sort of different plots for different lightnesses for that, given that hue. These are all assuming full saturation. I would assume most things to have a good contrast with black, which is why this seems suspect, but that's okay. What's some other things we can do with this plot? We have the min contrast and max contrast values. And right now they're kind of all over the place. So what I mean by that is that the values have like arbitrary decimal place precision. I don't know that that adds value. It probably doesn't, which means I'm going to, first of all, quick put a margin on this. Oh, and I have typos all up in here. There we go. So many typos. There we are. So we want to fix these numbers to be less sort of arbitrary. Let's see what the best way to do that is. We could say 2 fixed 3. 2 fixed 3. Let's see how that works. So this is very cool. I'm gonna quickly. I think this is somewhat new, but we have the idea of numbers in MDN, or sorry, numbers in JavaScript. You can give fixed point notation, right? So I'm saying give me a 2 decimal place in this case, but I could also say, if I said 3, and that's going to give a fixed number of digits after the decimal place. You used to have to do all kinds of tricks to do this. I forget, is this an ES6 thing? It is an ES 2015, so it's an ES6 thing. But that's pretty good. I think it's got pretty darn good support at this point. It's just oh yeah, look at that. Look at that green table. So if you just need a number, you just need to print it out, rounded to a number, 2 fixed. Can recommend. So now these look much nicer, much more tractable. You can see these plots kind of go all over the place. I love watching the A lines like race away. What's interesting here is this like floor of contrast. That tells me that I think there's something wrong with my calculation. But I think this is still really fun to play with. We've got hue versus luminance, text contrast, other color stuff. I want to take a look at some really cool color stuff on Glitch. Before we wrap up, there's this fantastic project about gradients. Gradient party sounds cool. Gradient thingy sounds cool. And pixel gradient maker. I know this one's cool. So we're gonna play around with pixel gradient maker. Yeah. I'll throw a link to this in channel. I just think this is the best. And you can just see, it just makes these really pretty dithered pixel gradients. And you can totally define what size they are. And you can totally pick the colors. See, this is my nonsense right here. Oh, and it's actually keeping track of all the ones I've made. Oh, that's so good. What else? I know Noah Lee's made some other really kind of incredible stuff. So we're going to look for animated pixel gradients. I think that's the one that is like my favorite. Yeah. Let's make a vaporwave gradient, shall we? I really don't love the default matte color picker. It's like not my favorite thing in the world. Look at this. Oh, it's so good. I think this is extremely high quality. The other cool thing about this website is once you're like, I like it a lot, you can hit render as GIF, and it actually builds you an animation out of it. There we go. So good. And so I hope some of the stuff I did with color today inspires you to do stuff with color. I definitely just scratched the surface. There's a lot of like color theory and color and like coming at it from an art school angle. I definitely came out of it as like a web, here are some numbers, how do we make them into pretty pictures angle. I hope something in here inspired you. I hope you play around with something colorful on the web, and if you do, totally let me know about it. I'm going to spend a little bit of time polishing up this project, and I'm going to then tweet it out. I'm going to put a little music on. If you have any questions for me, you can just drop them in the chat. Thanks so much.